All right, here we go with another example problem from the laboratory that we did today, laboratory exercise. Before we begin another equation, I'm going to remind you of a couple things about polyatomic ions and atoms associated with them. For most of these equations, remember we talked about finding charge. You're going to need to find the charge just by looking at the periodic table or knowing the valence electrons. However, there are a couple of them that have variable charges. For example, if you look at lead on your periodic table, all right, here's lead. You'll see that lead is a +2 or a +4 charge. See how it's listed as +2 or +4? Let me get it over there. Hang on. Lead, come on. There we go. See how it says 2 or 4? So you're going to have to know which is it. Is it 2 or is it 4? Here's how you're going to know. So you look back at your polyatomic ions down at the bottom of the page, and you see nitrate. Nitrate's right here. It's NO3 with a -1 charge. Do you recognize that NO3 -1 is what we had in the, nope, that's not the lab, is what we have in the lab. Let's get this out of the way so I can see what's going on with the lab. Okay, here we go. See this lead and this nitrate? There are two nitrates, and we just saw that each nitrate's -1. So what's the lead got to be? Nitrate's -1. There are two of them. What does the lead have to be? If you said +2, you are correct, because if nitrate's -1, then the lead has to be +2 to match the charges. Copper is another one that can change its charges. It can either be, it's supposed to be a small l, can't resist fixing that. So copper, if you look at it on a periodic table, it's either going to be +1 or it's going to be +2. Now see right here it is, see, +2, +1. So what we have to do is figure out which it is. However, if you look at chlorine on a periodic table, so you look at chlorine to tell, chlorine has 7 valence electrons and it's -1. For those of you who are wondering, see how it says plus or minus here and plus or minus here? It's positive if it's combining. These guys over here with 7 valence electrons can only be positive if they're combining with something that is more electronegative than them. So these two guys might be positive if they're combining with oxygen or fluorine, but usually they're -1, like they're supposed to be with their 7 valence electrons. So let's take a look at, I'll just do an example of copper chloride up here in the corner. So if we look at CuCl2, chlorine's -1, there are two of them, makes a total negative of 2. So that means 2 gained. Remember talking about that the other day? So the copper has to lose 2. There's only one atom of copper here, so that one atom must have lost 2 electrons, and so we know this is copper with a +2 charge. Now I can't write on this spreadsheet with my little pen, so you're just going to have to listen to me, but copper's going to be +2. Lead's going to be +2. You'll be able to tell the charges on the polyatomic ions by looking at your sheet, except for mercury, and I'm going to do a mercury one in just a second. So I think you're able to figure out the charges now for everything that we have in this lab. So I'm going to do one of the hard ones from the mercury row. Remember all those mercuries? So let's take a look at box 41. Yeah, 41's a good one. Yeah, 40, that's kind of easy. Let's don't do 41. Let's do a harder one. Let's do this box. So this one right here. 44. We'll do box 44. That's about as hard as they can get. So box 44. All right, in box 44 you had mercury 1 nitrate, and it combined with sodium phosphate. So remember that, mercury 1 nitrate. Here we go. Mercury 1 nitrate looks like this. That's supposed to be an H. NO3, notice the parentheses because there are 2 of these polyatomic ion nitrates, plus sodium phosphate. Notice this chemistry language I'm using. All right, now one other polyatomic ion that's not on your list is mercury 1. Mercury with a +1 charge always occurs in pairs. That's a little quirk of mercury. So it overall has a +2 charge. So it's like a polyatomic ion with a +2 charge. All right, here we go. Remember the little boy-girl thing we did? Boy, girl, cation, anion, cation, anion. I'm assuming you guys all remember. Cations, what are they? Positive or negative? Mr. Dillo reminded me that cats have paws. Cations, positive charge. Anions, of course, it tells you a negative ion. Or you can go back to cation. It's got a little plus sign right there. It tells you it's positive. All right, so cation, anion, cation, anion. They go to the dance. They change partners. You got sodium now with nitrate. Now you wouldn't put the two cations together. Be sure you don't put Na with mercury because that'd be like two positives and they'd repel each other. And then the other combination would be mercury 1, which always occurs in pairs. Remember that? Always in pairs. And PO4. All right, now we need to check our charges. Oh, by the way, what were those 3 steps I said in the last video? First was combos, wasn't it? Didn't we just do that? That's what these combinations are. Now we need to write formulas. Remember when we wrote formulas, I told you to use charge and subscript. And then we had to balance. There we go. So, let's write the formulas, check our charges. You look at your periodic table, do what it takes to know that sodium's +1. Has 1 valence electron, it's going to lose 1 electron. You might just remember it from the last video. Nitrate's -1. Look at the periodic table down at the bottom of the table. Do you remember what I'm talking about? Looking at nitrate. So you go over here, you come down to the bottom, look at the polyatomic ions. There it is, nitrate, NO3 -1. All right, NO3 -1. I don't know why hydroxide is highlighting. Ignore this over here. Nitrate -1, NO3. And then you look at mercury 1. We know it's +1 because mercury 1 is always +1. That's why it's called mercury 1. But it also occurs in pairs. Now, since it occurs in pairs and it's got a +1 charge and there's 2 of them, the charge will be +2. Even though it's called mercury 1, its charge is +2 because it's in pairs. Then phosphate on the periodic table will be -3. Would you like me to review that with you? So you go right here. I assume you said yes. Phosphate's -3. PO4, -3. All right, so now we can write the formulas. The idea of the formula, of course, is that the positive charge and the negative charge are equal, which would imply that the electrons lost equal the electrons gained. Is 1 equal to 1? Yes. Is 2 equal to 3? No. So we need to find a common multiple. What is the lowest number that 2 and 3 both go into evenly would be what? I'm hoping you said 6. So 2 goes into 6 how many times? Whoops, I'm pointing to the wrong 2. This 2. 2 goes into 6 how many times? I'm hoping you said 3. So you had to put parentheses around this because that is a polyatomic ion and put a 3 out there. And then the phosphate has a -3 charge. How many times does 3 go into 6? Hoping you said 2. So you're going to put a parentheses around here and put a 2 there. Now we've written the formulas. Remember what I said to use on formulas? Charges, is that what I looked at first? And then subscripts. So you manage the number of atoms by using the subscript. Now we're ready to balance the equation. What do you use to balance it? Use coefficients. Where do they go? In the middle? No. They have to go in front of the formula. So they could go here, or here, or here, or here. All right, so I'm just going to jump into something. I tell you what, I'll give you a little hint here, helpful hint. Usually when you're balancing equations, look at what you have the most of, and then try and balance from there. It'll save you some time. So in this case, we've got the most number of phosphates and mercury 1s, right? Right? How many mercury 1s are there? 3 times 2 is 6. On this side, there's 2. So what could I multiply 2 by to get 6? Now, I know that's a hard question, but I think you can do it. The answer is 3. Now, the consequence of putting a 3 in front of that is that it also multiplies the NO3 groups by 3. There are 2 NO3 groups, so 2 times 3 is 6. There are 6 NO3s. How many NO3s are over here? I'm hoping you didn't say 3. How many NO3 groups are here? I only see 1. Because NO3 is the polyatomic ion, and there's only one NO3 group. But on this side we had 6. So over here I'm going to need to put a 6. Well, that multiplies my sodium, doesn't it? Because there was only one sodium here, but now when I put a 6 there, there are 6 sodiums. So on this side there's 3. What I'm going to need to do then is multiply that by 2, because 2 times 3 is 6. Well, how many PO4s now do I have on this side? I'm hoping you did not say 8, because there's only one PO4 in this formula. When multiplied by 2, we now know that there are 2 PO4s because I multiplied by 2. Look how many are on this side. Ah, there are 2 PO4s. And that, boys and girls, is the balanced equation. So we've now done all 3 steps. So once again, you're doing these for the equations in which there was a reaction. You want to have as many of these done as possible by next class, because next class we'll learn a couple of new things to do with this lab. Finish the write-up and turn it in next Thursday. That's the end of this video. I think I'm only going to do these 2 examples because I did a very thorough job, don't you think? I hope. All right, talk to you later. Have a good weekend, and I'll see you on Tuesday.